Hey everybody, in this video we're going to work on identifying some logarithms, and what I want to do is I want to just start by trying to figure out a basic logarithm that isn't been modified, doesn't have like a negative in it, or isn't shifted up or down. So I'm going to think about the properties of logarithms, and I want to grab something easy, so I'm going to think something like log base 2 of x, and I want to try to think about some of the important points of the log base 2 of x. Now, the log base 2 of x would have, let's see here, the log base 2 of 1. When x is equal to 1, this better be equal to 0. The log base 2 of 2, right, that would give me 1. The log base 2 of 1 half would give me -1. And well, since it's 2, I can go ahead and say, like, if I square 2, so that's the log base 2 of 4, I better get 2 out of it, right? It better be squared. Now I chose blue to write this all out on, kind of on purpose, because I saw this right away. I saw the point 1, 0 right away, and that's this point. So I was eyeballing this blue line to start. Then I'm going to go over to x is 2. So here's 2, and it's at 1. That matches. 1 half. So is -1. So I move x over to 1 half. Remember, this is my x right here. X, 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 and then this is my y, y, y. X at 1 half, so less than 1, it's suddenly negative. Yeah, -1, 1 half, that seems to fit. I move x way over to 4, and I've only gone up 1, right? And I'm at this point, 4, 2, and that checks out. So I'm going to guess that this is my basic logarithm here. This is log base 2 of x. That's my basic logarithm. Okay. I want to try to look at some of these other ones. I'm looking at this orange one seems pretty interesting. This orange one seems pretty interesting right here. Take a look at this, because it's going through this point. It goes through -1, 0, so I'm thinking this is the x mirrored. I'm thinking this has got a negative x in it. This is the log of some base with a negative x. And then, because then we go out here to 1, and we get something there. We go out to, let's see here, this is something between, let's see here, -1, 2, 3. Interesting. So in between 2 and 3, it's at a height of 1. So this right here is equal to 1 when x is between 2 and 3. And you know what in between 2 and 3 is in code for logs and exponents? E. So I'm guessing this is a log base e of -x. And then that would mean if I go out to like 5 and change, it'll be at 2. Yeah. Alright. So I'm going to go ahead and I'm going to guess that this is something like the natural log of -x. That seems like a pretty good guess. I want to look at this black line, and I'm looking at how it's going through 0, 0, and that's 1 away from there. So I'm thinking that what happened with this black line is it went to the right 1, and it's pointing this way, right? And it curves like this, which tells me it's got a -x. So -x plus 1 or 1 minus x. That's what's inside the logarithm. Now, I could try to identify the base. Not really too sure. It looks like it's going to be something around e, but a little bit bigger because this comes out down below this one that was at e that we're looking at. So I'm thinking it's a little bit bigger. If I go to negative 2, that's at 3. So negative 1, negative 2. And this is right here at 1. Ah, okay. So we've got the log of some base. And when x is negative 2, a negative 2, plus 1, we said, it's equal to 3. So the log of some base of 3 equals 3. That base is 1 because 3 to the first power is 3. So I'm guessing right here that for this black line, this is the log base 3 of, let's call it minus x plus 1. Cool. Now I want to look at this green one because it goes through this point. And like our basic log 2 of x, that means that at 1 we get 0. And you know what? Negative 1 times 0 is still equal to 0. So this was mirrored and it's flipped upside down. So we've got an upside down flip to this. So this is negative the log of some base of x. And I don't know what this base is. What's b going to be here? Well, I'm going to look at this line, negative 1, see where it comes. Whoa! Negative 1 is off the scale. So 5, 6, 7, 8. b is greater than 8. So you know what's a really common base that's greater than 8? 10. And so my guess would be that this green line right here, this green line would be negative log x. Pretty good guess. Okay. Lastly, we've got this red line to deal with. Lastly, let's take a look at this red line. It goes through, whoa, height 0. It's way out there. Let's see here. It goes through 1, 1. That's weird. And it's really super steep too. See how this line right here, there's this weird symmetry between the red and the green lines somewhere along this line maybe. I'm looking at where they crossed over. And I'm like, yeah, this shape comes down just about as steep as this does. This comes up just about as steep as this does. These are really similar. Except here's the thing. If I'm going to mirror them, right, if the green line is negative the red line, then it should be mirrored about this axis, right? That's how mirroring works, is you take, and you've got your horizontal axis, and then your red line comes up and it goes, and then your green line comes over and it goes, something like that. But it's not. This line's right here. So I think this whole red line right here, I think this got shifted up. And again, I'm looking at this point when it's at this, when x is at 1 right here. So the log of some base of 1 is equal to 1. To me, that's screaming that somebody added 1 to it. Because this right here, the log of some base at 1, better be 0. Something in this whole thing went up 1 because of this point right here. And then, let's see here, what's some other points? When it's at height 1, So that would be at height 2. It's way off the scale at height 2. It's approaching this height 2 type thing, right? Just like this approached 10 over here. So I'm guessing that this red line is going to be log x and then plus 1 outside of the logarithm. The log of x, whole thing plus 1. Whereas the whole thing seems to be shifted up 1. Okay. That's it for this video. Thanks. I'll see you next time.